Grade 12, let's talk about limits. Now, limits is something that feels like a weird concept, and many times people don't understand it. But let's talk about it, and let me help you through it, okay? So I'm going to start off with just an equation of a graph. So let's say, for instance, you have a graph that looks like this. Gx equals x squared minus x minus 2. Let's say that is your graph. And I ask you to draw the graph for this equation. What you will do is you will factorize, right? You will make this equal to 0. And then from there on, after getting your factors, you have your x-intercepts and the y-intercept, right? So from here on, we know it's 2 or negative 1. So now when we draw this graph, it will look like this. Intercept at negative 2. Like I said, I'm just doing this as a conceptual graph, right? It will look something like that. Okay, all of you can do this, I'm sure. And we didn't focus on the turning point now because that is irrelevant to this explanation. So we just want the concept. So this is negative 1, 2, negative 2. Okay, now, keeping this equation g in mind, I'm going to ask you to do the exact same with equation fx. But fx looks like this: x squared minus x minus 2 divided by x minus 2. And now, this is a different story, right? So now we're uncertain, but we don't have to be. Okay, first of all, let's look at our denominator. We know the moment you have a variable inside the denominator, you are going to have a restriction. So our restriction will be x minus 2 may not be equal to 0, therefore x may not be equal to 2. Okay, when x is equal to 2, this will become undefined. Okay, now let's look at the equation at the numerator. By looking at the previous example, you know we can factorize it, and it will become x2 times x minus 2 times x plus 1. So this will become equal to x minus 2 times x plus 1 divided by x minus 2. Now, mathematically speaking, we can just cancel these two brackets out, right? And then it would become x plus 1. And that is the final answer. Keeping in mind that we have a restriction over there. Okay, so let's draw this graph now. And you will see that this is a straight line graph, x plus 1. One that's very easy to draw. It is a plus 1 gradient. The y-intercept is 1, so it will just look like this. But now we need to keep in mind that we had a restriction. Our restriction was that x may not be equal to 2. So this is one that's negative 1, so 1, 2. So where x is equal to 2, at that point on the graph, it may not be equal to that value. And as you guys know, that the moment you have an open circle, that means it excludes that value, right? So this function will look like a straight line graph. It is a straight line graph, perfectly as is, but at that point where x is equal to 2, it will not exist. Now, just for the fun of it, right? If we put x equals 2 into this equation, x plus 1, we know that over here it would be 2 plus 1, which is 3, right? Now, substitute the 2 into this equation, and you will immediately see it will be 2 squared, which will, I'll just write it down here next to it. It will be 2 squared minus 2 over 2 minus 2. What's going to happen? It will just become 0, right? And then the denominator will become 0, and that's the important one. That makes it undefined. But we know that this equation is also equal to x plus 1 with the understanding that we have a restriction added. So if you look at the graph, it will be equal to 3, but it would not exist. Now, do me a favor, substitute 2.01 into this equation, and you will see you'll get an answer very close to 3, but just a little bit bigger than 3. And if you substitute 1,999 into the equation, you'll also get the answer very close to 3, but it will not be equal to 3. And that's basically a limit. That's basically what it means. We know it does not exist, but we want to understand it. So we are looking at what it will be as it approaches that value. Okay. And let me write down the actual limit. Okay. So this is the solving of it, but as already seen on the graph. Okay. But when we write down a limit, it will look like this. What will be the limit when x approaches 2? That arrow means approach. It's not equal to 2, but if it comes close to 2, what will be the limit of x approaching 2 of x squared minus x minus 2 over x minus 2? So when we do this, we will follow the exact same calculations that we've done, and then those will cancel out. So it will basically simplify to this, right? Now, when we're at a place where we can substitute 2 in without it coming undefined, like over here and over there, we can do it because the limit as x approaches 2 for x plus 1 will be equal to 3. And this correlates with your graph right here at the bottom. But you can see it has to be a limit because it does not exist. It's just approaching that value. It's the same principle with something approaching infinity. It will never reach it, but it approaches it. How does it look like? Thinking of geometric sequences and geometric series with the sum of infinite terms. That's the same thing. It's a limit. Or as x approaches 0, what will happen? You know, that type of thing. Okay, I hope this clears it up.